Hey everyone, and welcome. Today, we are diving into a skill that is, seriously, one of the most important in the tech world, SQL. Think of it as the one language that lets you talk to pretty much any kind of data. And trust me, by the end of this, you're going to get what all the fuss is about.
Look, we are swimming in data these days, right? Sales numbers, user clicks, you name it. But just having a mountain of data doesn't really help anyone. The real challenge, and honestly where the real power is being able to cut through all that noise, ask a super specific question, and get a precise answer back. So, how do we wrangle all this chaos? Well, that's where the database comes in. At its heart, a database is just a way to collect information in a really structured way. The best analogy? It's like a gigantic, perfectly organized digital filing cabinet. Everything has its place. You just need to know how to ask for it. And that brings us to the big question. How do we actually talk to this digital filing cabinet? We can't just shout at it. We need a common language that everyone agrees on, one that the database understands perfectly. And that language is SQL, which stands for Structured Query Language.
Okay, quick detour, but this is pretty important to know. There are kind of two main ways to think about storing data. On one side, you've got your SQL databases. Think of these like building with a blueprint. Everything is planned out beforehand, it's very structured. On the other side, you have NoSQL, which is way more flexible, kind of like working with clay. For today, we're sticking to the structured world of SQL.
So, SQL isn't just one big thing. You can break it down into three main jobs. First up is DDL, Data Definition Language. This is all about building the filing cabinet itself and labeling the drawers. Then you have DML, Data Manipulation Language, which is for actually putting files in, taking them out, and changing them. And finally, there's DCL, Data Control Language, who's basically the security guard deciding who gets the keys to which drawer.
All right, so let's tackle that first one, building the structure. It makes sense, right? Before we can put any information in, we have to build a container for it. This is exactly what those DDL commands are for.
Creating a table, which is really just one drawer in our cabinet, is a super simple three-step process. First, you give the table a name. Easy enough. Second, you decide what columns you need. What kind of information you're going to store. And third, you tell the database what kind of data to expect in each column. Is it a number, some text, a date?
And here's what that plan looks like as actual code. We use create table and name it customer. Then we list out our columns, like cust ID and cust name, and give each one a data type, like int8 for a number. We can also add some rules. See that primary key? Think of that as a unique ID card for every single customer. No two can be the same. And not null is just us saying, hey, this is important info. Don't let anyone leave this blank.
Okay, so our filing cabinet is built and the drawers are all labeled. Now for the fun part. Let's actually put some files in it. To do that, we're going to switch over to those DML or Data Manipulation Language commands.
To get a new piece of information into our table, we use the insert into command. And it's really logical if you look at it. We say which table we're inserting into, we list the columns we want to fill, and then we provide the values that match up with those columns. Simple as that. And voila! After running a few of those insert commands, our empty table structure is now full of life. It's filled with actual, usable data. Each row is now a complete record, a single file sitting neatly in our drawer.
Of course, the real world is messy, and data is constantly changing. That's where update and delete come in. Update lets you change a record that's already there, and delete lets you remove it completely. But, and this is a huge but, you have to pay attention to that where clause. It is your safety net. It tells the database exactly which record to change. If you forget it, you could accidentally update or delete your entire table. Seriously, it is that important. All right, now we get to the part where SQL becomes a superpower. We've built the structure, we've filled it with data, now it's time to ask it questions and find exactly what we're looking for. We call this querying the data. So let's pretend we have a big table with info on all our students. That's great, but what if your boss only wants to see the top performers? You're not going to scroll through thousands of rows by hand. So how do you filter out all the noise and just get a list of the A students? And the answer is our good friend, the where clause. When you pair it with a select statement, it becomes this amazing filter. This query right here is basically us saying in plain English, hey database, select the names from the classroom table, but only give me the ones where the grade is an A. But what if you don't know exactly what you're looking for? Maybe you only know the first few letters of a name. That's where the like operator is a lifesaver.
You can use wildcards, like the %sign, which basically means match any sequence of characters here. Or you can use the underscore, which is more specific. It means match any single character right here. It gives you so much flexibility when you're searching.
So pulling individual records is cool, but the real aha moment with SQL, the thing that turns data into actual business intelligence, is when you start summarizing it to see the big picture.
We do this with something called aggregate functions. You can think of them like superpowered calculators built right into SQL. They take a whole bunch of rows and crunch them down into a single value. You can count how many there are, get the sum of a column, find the AVG or average, or grab the minimum or maximum value. These are the tools of data analysis. Okay, so let's look at this table of raw student data. We can see each student, what year they're in, their subject. The information is all there, but it's hard to see any real patterns, you know? It's just a list of facts. And now, check this out. Using the count function with a group by clause, we've completely transformed that messy list. Instantly, we have a clean, simple summary. We haven't just found information, we've literally created a new insight. We now know exactly how many students are enrolled in each subject.
And what if you want to filter these new summaries? That's what having is for. It's a bit like where, but with a key difference. Where filters the raw rows before they get grouped. Having filters the groups after they've already been summarized. It lets you ask questions about the summary itself.
So at the end of the day, what is SQL? It's not just a bunch of commands. It's a way of thinking, a tool that lets you have a direct conversation with your data. It's how you turn those endless spreadsheets of raw information into clear, actionable answers. So the only real question left is, what problems are you trying to solve?